Welcome to Coding with T, and I'm your host, Tiffany.
Hey Codies, quick disclaimer. From this point on, I'll be dropping videos every Monday and Wednesday at 3:30 Central Time, so stay tuned.
In this video, we will be working with LinkedList. So make sure you're caught up on all the videos because in the last video, we worked with ARRAYLIST methods. And although linked lists are similar to ARRAYLIST in terms that they both implements the list interface, they're different. And the main difference between an ARRAYLIST and a linked list is how it's implemented. So to explain more, ARRAYLIST implements as a resizable array. So this means as elements are added, the size increases dynamically. Furthermore, anytime an element is added to an array list, the element that comes next is shifted. For example, I have the following list below. My array 1 is initialized to 3 strings. These strings, as you can see, includes hi in index 0, Codies in index 1, and welcome in index 2. And suppose I wanted to insert the string team into index 1 position. Every element after hi would be shifted. Also, when elements from an array list is deleted, every element after the deleted element is shifted up. In some cases, there may be a significant delay if the array list is large. But in contrast, if you're writing a code that doesn't frequently add or delete elements from a list, it's more likely, it's better to use a linked list. So, to explain more, linked list stores the addresses of the elements before and after each element. So here's an example, and just to kind of explain what's going on here, hi is in the first element. As you can see, there is no element before it. Therefore, the box on the left shows the arrow pointing to null. And just in case you don't know what null means, it means that it's pointing to nothing or an empty value. Now the box on the right stores the address 1, 2, 3. Which is the address of the next element. The next element has Codies assigned to it, and the box on the left has the address 1, 1, 2, which is the address of the previous element, while the box on the right stores 1, 3, 4, which is the address of the next element. If there's a case where you want to delete the Codies element, here's what it would look like. So according to this example, the box on the right side of hi stores the address 134, which is the address of the element welcome. And just to clarify, if this list implements as such, there is no need to shift any elements when elements or an element is added or deleted. See, what happens is the address is updated when it's necessary. Additionally, linked list class implements the DEQUE and the DEQUE interface, as well as the list interface. The DEQUE and the DEQUE are part of the Java collection framework. Furthermore, linked lists have access to methods that ARRAYLIST cannot even use. So here's a few of those methods that ARRAYLIST does not use. We're going to talk more about these methods on the next video, and I'm also going to show you how to use these methods. One of the things that I like about linked lists is that they have a higher memory consumption in opposed to an array list. But the downside to linked list is that it's more time consuming in terms of finding a specified element in a list. Whereas ARRAYLIST can calculate the address of each element based upon the first element. So that may be something to keep in mind in terms of trying to figure out which list you want to use. Now I'm going to move on so I can show you all how to declare and instantiate a linked list. In order to instantiate a linked list, we type linked list. Inside of these arrow brackets, we're going to use the object integer. And then we're going to create a variable. We're going to name it myLinkedNums. And we're going to instantiate it to new linked list. Just like this. So yeah, here's how you instantiate a linked list, which is similar to how we instantiated our array list on the last video. The difference is we use linked list instead of array list. So in order for everything to work as expected, we also have to import linked list. Lastly, I want to show you how to declare a list and assign it to a linked list. Okay, so let's finish strong. We're going to type list, and inside of these arrow brackets, we're going to type our object, which is an integer, and we're also going to name our list, our variable, myListNums. And we're going to instantiate it to new linked list. Additionally, this is the way the list class must be imported. Okay, Codies, we're going to end it here. If this video helped you out, make sure you smash the like button, subscribe, hit that notification button, and also drop a comment and share the video. Thanks for watching. Catch you on the next one.